Hey everyone, my name is Lena Wojtek and this is my eSociety 210 final presentation video. In this video I will be showing off the capabilities of the Remote Ambulatory Motorized Broadcast Operation, or RAMBO for short. Since the actual operation of the vehicle is fairly straightforward, I will also be going through the process of building it and the Python, HTML, and Bash programming I did to complete it. The basic concept of RAMBO is a vehicle that has directional inputs and a live video feed output, both of which can be accessed from a remote source. Inputs to the vehicle can be done through an attached wireless keyboard or over a web browser. In a later version, the vehicle will have full access through an Android phone's Bluetooth or a PC C# application, both of which are currently in development. The live video feed is currently available through any web browser connected to the Raspberry Pi's IP address. The vehicle currently takes in 5 possible inputs: forward, left, right, stop, and shut down. These commands are sent in using WASD and Q on the keyboard. Through a Python program, these inputs are translated into electrical signals that control the 2 motors on the vehicle. When Q is pressed, the Python program stops and the Raspberry Pi shuts down. The final operation of RAMBO ends up being very simple. Currently, all inputs and outputs on the RAMBO vehicle are based on the camera, Wi-Fi, wireless keyboard, and the onboard motors. All user inputs are single characters sent into the Raspberry Pi generated by keyboard presses. Alongside this, the USB webcam on the vehicle sends an input of 1 new image every 2 seconds. The first output from the vehicle is a set of binary GPIO pins on the Raspberry Pi. With every input, some of the pins will lose power while others gain some. The combination of on-off will tell you which motors to activate and to move the vehicle. The second output is the image generated by the webcam. This image is sent via the Raspberry Pi's web server, which is told to refresh every 2 seconds to retrieve the updated image. The Wi-Fi interface is made possible by the third-party Apache web server that turns the connection to a Linux computer into a personalized website. The camera interface is done through a third-party software called FS Webcam and gives the user control of their webcam through a command line interface. Finally, keyboard inputs are made possible by a Stack Overflow user who solved Python's inability to take immediate inputs through some input stream manipulation. The wiring of this project is straightforward for everything but the motors. A portable battery is attached to the micro USB port of the Pi, causing it to start up when the battery is turned on. Attached to 3 of the Pi's USB ports are a white official Raspberry Pi Wi-Fi dongle, the webcam, and the wireless keyboard connector. The motors are more advanced in their wiring, and they must be connected to a set of 6 GPIO pins. To do this, a 16-pin chip called the L293D is placed on a breadboard, so all inputs and outputs go where they need to. 4 AA batteries provide power to the motors, while the 6 GPIO pins decide whether the motors receive that power. The Raspberry Pi also provides a 5-volt input and a ground for the circuit with 2 extra wires. The main program that I developed for this project takes in keyboard input and sends power to the pin outputs. It is written in the Python language. The program starts off by importing necessary files and sets the mode, which is currently wireless keyboard input. GPIO pin numbers are set as variables to make the code easier to understand. Then they are defined and set up in output mode. The functions for each of the motors' movements are then defined, each with the proper combination of pin outputs. These directional commands are then used later in a while loop that repeats with every key press. When a key is pressed, the designated function is called. If Q is pressed, then the loop ends and the pins are reset. The second program, which is imported by the first, is a function that can understand key presses. It constantly searches for a key entry in the terminal, then translates it automatically into a character that is sent to the first program. The final program is in HTML and the main web page that is accessed through the Pi's IP address. It starts with a website title, then tells the browser to refresh every 2 seconds. It then uses JavaScript to take in the key commands from the keyboard. These commands are then displayed on screen. A stronger UI for the inputs to the Pi will show up later on. After the JavaScript is an HTML form object that allows the user to type in characters. Finally, the web server shows the live video feed by putting the most recent image in the body of the web page. That covers most everything about the RAMBO project. Thanks for watching this video from my eSociety 210 final project. Bye!